Welcome to the DIY Honda Garage channel. This presentation focuses on diagnostic trouble code DTC P0327, which signifies a knock sensor circuit low voltage issue, specifically in the Honda Civic model from 2022 and beyond. The knock sensor is a critical component that detects vibrations in the engine, primarily to prevent knocking or pinging, which can harm the engine's performance. It plays an essential role in adjusting the engine's ignition timing to optimize fuel efficiency and performance. The Powertrain Control Module, PCM, relies on the input from the knock sensor to make adjustments to the engine timing. Thus, a fault in this circuit can significantly impact engine operation. The problem is essentially a low-voltage signal from the knock sensor, leading the PCM to store this DTC as a protective measure. We'll follow a systematic troubleshooting approach to identify the root cause of this issue and determine the necessary repairs. DTC P0327 indicates a malfunction in the knock sensor circuit, where the output voltage from the knock sensor is below the specified value set by the manufacturer. The knock sensor, located near the engine block, measures engine vibrations and provides input to the PCM to adjust engine timing. If the voltage signal drops too low, the PCM interprets this as an abnormal condition, triggering the DTC. This situation can arise from issues in the sensor itself, wiring problems, or malfunctions in the PCM. The correct functioning of the knock sensor is essential, as it helps protect the engine from knocking, which can lead to severe engine damage. This DTC must be addressed promptly to maintain optimal engine performance and reliability. Several factors can lead to the activation of DTC P0327. Firstly, a faulty knock sensor is a primary suspect. This can occur due to internal damage or wear over time, which affects its ability to generate the correct voltage signal. Secondly, shorted wiring in the circuit could prevent the proper signal from reaching the PCM. This could involve a wire being damaged or frayed, creating a direct connection that sends incorrect voltage readings. Finally, a malfunctioning PCM could be the cause, especially if other components have been ruled out. Each of these possibilities must be thoroughly investigated during the diagnostic process to pinpoint the actual problem. Identifying the root cause is crucial for effective repair and ensuring the vehicle operates efficiently. The symptoms associated with DTC P0327 can significantly impact overall vehicle performance and drivability. One of the main indicators is the illumination of the check engine light, which alerts the driver to a potential issue in the engine management system. Additionally, drivers may notice reduced engine performance, such as insufficient power or poor acceleration, due to incorrect timing adjustments made by the PCM. Rough engine idle can also occur as the PCM struggles to optimize engine timing without accurate feedback from the knock sensor. These symptoms can affect how the car responds under different driving conditions, compromising both safety and efficiency. It is essential for any driver experiencing these symptoms to seek prompt inspection and repair to avoid further complications. The first troubleshooting step for DTC P0327 involves turning the vehicle's ignition to the on position without starting the engine. This enables power to the vehicle's electronic systems and allows you to perform preliminary checks on components related to the DTC. It's essential to review the service manual for specific diagnostic procedures and preparation required for testing. Ensure that the technician is familiar with the exact location of the knock sensor and PCM in the vehicle. This preparation is critical as it sets the foundation for an effective and thorough diagnostic approach. Make sure all tools and equipment are available and in good working condition to facilitate the inspection. Effective preparation can significantly enhance the efficiency of the troubleshooting process. The next step is to disconnect the knock sensor's 2-pin 2P connector. This is essential to check the integrity of the wiring and connection. Once disconnected, it is crucial to inspect both the connector and the wiring for any visible signs of damage, corrosion, or loose connections, as these can all impede the functionality of the knock sensor. Carefully examine the pins within the connector for proper seating and cleanliness. If any visible issues are identified, they should be addressed before proceeding with further tests. Making sure that the connections are clean and secure can sometimes resolve the issue and prevent future problems. If no visible damage is found, continue to the next testing phase to evaluate the sensor's output signal more critically. In this step, the technician will check the signal voltage output from the knock sensor. This involves utilizing a multimeter to measure the voltage while turning the vehicle to the on position. If the voltage is below the specified range, it indicates a fault in the knock sensor itself. It's important to establish normal operating conditions before doing this check to ensure accurate results. Confirming that the DTC P0328 is indicated during this test would reveal that the knock sensor is indeed malfunctioning. If the voltage readings are normal, it signifies that the issue might reside in the wiring or the PCM, warranting further investigation. This comprehensive analysis ensures that the exact source of the malfunction can be accurately determined for effective repair. The fourth troubleshooting step involves inspecting the external wiring circuit for shorted connections. Before moving on, it's recommended to disconnect the PCM connector for safety. Utilize appropriate diagnostic tools to verify the resistance across the knock sensor circuit. Specifically, look for any signs of shorted wiring or resistance that doesn't align with the expected values, which should be greater than 1 megaohm. Referring to the user manual will provide guidance on identifying specific wire colors and pathways. If there are any abnormalities in the wiring, they must be addressed immediately to restore proper circuit functionality. Handling this inspection thoroughly is vital for preventing potential future issues with the sensor and ensuring the entire engine management system works optimally. The final troubleshooting step requires reconnecting the powertrain control module PCM for further testing. Ensure that all previous checks on the knock sensor and its wiring are completed before testing the PCM directly. The technician should monitor the PCM's operation and assess whether the other inspection items indicate normal conditions. If everything else appears to function correctly, but the DTC persists, the most likely cause is a malfunctioning PCM. This constitutes the last part of the troubleshooting process, and if a PCM issue is confirmed, consider reprogramming or replacing the unit as necessary. Accurate diagnosis of the PCM is vital, as it plays a significant role in controlling various engine functions and ensuring overall vehicle performance. Upon completing the inspection, note all observations and results for documentation purposes. After completing repairs and parts replacements, it's crucial to perform a final verification to ensure that the issue related to DTC P0327 is successfully resolved. Begin by rechecking all components related to the knock sensor and PCM, confirming that they are functioning correctly. Following this, clear any existing DTC codes from the PCM to eliminate stored errors. Once codes are cleared, proceed to conduct a test drive of the vehicle under diverse operating conditions, observing for any signs of performance issues or recurring check engine lights. This real-world testing will help in validating the repair and ensures that the vehicle operates normally. Finally, document any findings from the test drive and confirm that the repairs meet the manufacturer specifications for long-term reliability. To prevent future occurrences of DTC P0327, it is advisable to implement a routine preventive maintenance schedule. Regularly inspecting the knock sensors and associated wiring ensures that any wear or damage is identified before it leads to a more significant issue. Ensure that connection points are clean and free from corrosion, as this can significantly affect performance. Conduct periodic checks of the wiring harness to maintain good connectivity throughout the vehicle systems. Additionally, maintaining the engine's overall condition can prevent excessive vibrations that could affect the knock sensor's operation. By adopting these preventive measures, vehicle owners can enhance reliability and prolong the lifespan of key engine components, ensuring smoother operation. In conclusion, understanding the implications of DTC P0327 is essential for effective vehicle maintenance and repair. This troubleshooting guide provides a systematic approach for diagnosing low-voltage issues in the knock sensor circuit. Each troubleshooting step helps eliminate potential causes, allowing technicians to pinpoint the root of the issue efficiently. Additionally, recognizing and addressing symptoms promptly is crucial in maintaining engine performance and reliability. To mitigate future complications, implementing recommended preventive measures can significantly improve the longevity and functionality of the engine's management system. Staying proactive in vehicle maintenance is key to ensuring a healthier engine and an overall better driving experience. Please like and subscribe to the channel. See you next time.